Let's run through chapter 20, numbers 9 and 10. I'm not going to draw this as not as nicely as it is in the textbook, but you have a very nice drawing of the textbook. So I'm going to just kind of loosely sketch it, and you can compare my sketch to the textbook, and I'm pretty sure it will make pretty good sense. Here we go. Number 9. Consider the movements that take place from one point to the next, A to B to C, and so on, along the total utility curve as the individually successfully increases consumption by one more unit, and then answer the questions that follow. It doesn't say units of what, so I tend to refer back to my lemonade. So what we have in the book looks something like this. There's the consumption of the good, and there's the utility from the good. When you don't have any, you have no utility, and then we have a curve that goes like this. That'll do. I think that'll do. Letter A in the question, not to be confused with point A, but letter A, which one unit increase in consumption from one point to the next along the total utility curve generates the highest marginal utility? Well, if you look across that, you can see that the biggest jump comes from the first, I would say, cup or glass of lemonade when the utility goes up to 5. And that corresponds to point B. From A, which is labeled down here in the book, to B, you have the biggest jump in total utility. Your marginal utility is greatest for the first unit. You get the most satisfaction from the first one. Then, letter B, which one unit increase in consumption from one point to the next along the total utility curve generates 0 marginal utility? Okay. Well, let me let you in on a secret. What we're doing, what marginal utility is, could be expressed like this. Marginal utility is equal to this jump, how much you got from it, over how much it was. Think about that. That's the change in Y, or the change in utility, over the change in this thing down here. So it's your change in total utility over your change in consumption. This one was 5. Why was it 5? Because total utility went up by 5 for 1 unit. In mathematics, in algebra, what is slope? A couple ways to think about it. One is rise over run, right? Slope we usually abbreviate with an M is equal to rise over run, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is the same as saying the change in y over the change in x. See how that's the same thing? The slope from here to here is 5. Letter B in the question says, where's the marginal utility 0? Well, mathematics is actually, if you're getting comfortable with that, it's kind of the easier way to see where the marginal utility is 0. It's where the slope is 0. Where's the slope 0? Right there. It's flat right there. Another way to say this is where it's flat. But I wouldn't have job security if we said things like that. So where the slope is 0, I'm only listing now the points that are the answers to that are the answers to the question for number 9. So where the slope is 0 is from E to F, or where the marginal utility is 0 is from E to F, and that corresponded to going from 4 units to 5 units, because the total utility was the same. The change in utility was the same, was 0. The total utility was the same at 11 units or 11 utils of utility for that 5th, let's say, glass of lemonade. 5th unit of consumption. Letter C in the question, which one unit increase in consumption from one point to the next along the total utility curve generates negative marginal utility? Well, these are all these are positive, right? The next unit brought you less utility than the one before it, but this one brought you 0 utility. It just kept you right the same. Where does it start to hurt? That's when you go to point G. And that's G. That is due to the 6th unit or cup, glass of lemonade, or whatever this is that's making you hurt. So that really is the answer to number 9. Now, let's see if I can squeeze in down here the answer to number 10. And I kind of want to put it down here because these things can fall right in place fairly well. What we're doing with number 10 is actually graphing the first derivative of that function using math terms. That's what we're doing. If you're taking a pre-calc class, you're starting to do this probably. That's what we're doing here, except this function is this relationship that we've described. These are variables that are measuring things that are kind of abstract, but they're real things. The satisfaction we get from something like glasses of lemonade. So let's go ahead and do this. Number 10 reads like this. Draw a marginal utility curve corresponding to the total utility curve depicted in problem 20-9. So I'm going to try to fit that in right down here below this one. And the reason I want to do that is because my control variable C is the same thing. This is going to be the graph of marginal utility that I've put there. So let me see if I can line my 1 up with my 1, my 4 up with my 4, my 5 up with my 5, and my 6 with my 6. And you know what? I don't have a 1 here, but let's fit in the 2 and the 3. They're not on there because they weren't part of the answer to number 10. Now, I'm going to make an adjustment. Make sure you can see this. There. I'm sure you can see that now. I don't want to risk this not being visible. So, let's see. Think of it as slope for just a second. What was my change in U utility, or for my change in consumption from point A to point B? I went up 5 and over 1. If I divide by 1, it's 5. Or put in simple terms, how much utility did the first unit or glass of lemonade, whatever, how much did it bring me? It brought me 5. So the first point on this curve of my total utility is 5. That's what the first one brought. Now what did the second one bring? The second one, I don't have labeled there because it wasn't part of the answer for number 9. The second one, my utility, total utility went from 5 to 8 when I had this second glass, and that is where point C is back in the model, and that was from 5 to 8. So what's 8 minus 5, or my change in utility, is 3. So my second cup or glass brought my marginal utility of 3. Brought me your marginal utility of 3. That's the slope from here to here. And that's the slope of the second glass. That's what it did for you. It brought you 3 units of utility, or 3 utils. The third one, also not on this, because it wasn't part of the answer to number 9. My third one, the total utility rose to 10. So there's this. The third one, total utility, should go to 10, and 10 should be just south of 11. That's not bad for a sketch, is it? There's my 10, right there. The third one brought me 10, and that's point D back in the image in the textbook. That's 2 more than the second one. So the third one, what it actually brought me, the marginal impact of the third unit, was 2 utils. And that's probably a little shy for 2, isn't it? Because I need room for 1. Something like this. And now my fourth glass, or units of consumption, it doesn't say what the good is, I went to point E. And point E was only, the total utility was only 1 unit higher than it was for point D. That fourth glass only brought me 1 unit of total, more unit of total utility. My marginal utility of the fourth glass was only 1. So I'll put that 1 there. And there it is. Now the fifth glass didn't bring me any more total utility. That slope was 0. That's okay. The marginal utility is 0. That's a place. We can plot that. The 6 might look tricky, and I'm not sure if it's showing up on my screen, but I'll say it out loud so you can see it or hear it and know what I mean. When I went from point F to point G, or drank that 6th glass of lemonade or consumed that 6th unit, we had negative marginal utility here. That was the last part of number 9. Negative 1. Well, negative 1's plottable. Look at that. I just do it like that. There it is, negative 1. And it would be like here. Put these together. And you have graphed the marginal utility of consuming this good. You've also graphed the first derivative. So if you haven't had pre-calculus, pat yourself on the back. You've graphed the first derivative of a function for the first time today. What that is the slope at each of those points graphed there. And it shows us sort of more directly that marginal utility is a falling thing that goes negative. I'm sure you were just dying to know that.